Welcome to Seen Solved, presented by Hubbard-Hall. My name is Tim Pennington. I'm the editor of Finishing and Coding, and today we're going to be speaking with Fernando Carminoli from Hubbard-Hall. And our topic today is going to be kind of two things in one: cleaning and heat treating. We're going to be talking about that. But first, Fernando, thanks for joining us today.
All right. Hey, team. Thank you to having me. Great opportunity to talk about cleaning.
I'm Tim Pennington, and you're listening to Seen Solved, brought to you by Hubbard-Hall. Better results, less chemistry. You've been out on the road a lot. I think you've been at a couple trade shows and visiting customers and doing a lot. Been pretty busy the last couple months, I guess, or?
Yeah. I cannot count how many shows we did so far this year. One specific for heat treat. And others all related with surface finishing.
Right.
Yeah. We're all the time on customers, distributors, all the end users supporting. Yep.
Yeah, I think I met you maybe 10, 12 years ago, I remember, right? How long have you been in this industry?
So I've been in this industry for 19 years already.
19, wow. Okay.
Yeah, 19. So I started in another country. I started in Brazil. I moved to US this year, going to be 10 years.
Right.
And always on the surface finishing, all related with electroplating.
Right.
But after that, more trained into cleaning, all different kind of cleaning. On the beginning, more related on the aqueous cleaner, washers, spray, ultrasonic, and also now with Hubbard-Hall, both initiatives with aqueous and solvents.
Right. Yeah, you can't plate unless you clean. That's the thing. You got to get the first part right, or you're not going to be very good at the second part, right? I mean, it's something a lot of people learn the hard way, right?
There we go. First come first. Cleaning would say this is the most important step, not because it's only the first one, but if you screw the cleaning, all the process will be bad quality. We used to say cleaners could be cheap, but if you have a bad cleaning, this is for sure going to be expensive. That's our quote.
That's correct, right? Because you're talking rework, you're talking rejects, you're talking a lot of things that can happen. Very costly, very, very costly. And plus, not just the rework part, but you probably run a risk of losing a customer. A plating shop could, if they're going to be not really putting the time and effort, learning how to do the cleaning right. And I've often felt it's doing it right it's difficult, but it's very methodical, and you just have to stick with it and do it the right way. Correct? I mean, that's what I've often seen.
Yeah. If you do correctly on the first time, that is how you're gonna save, how you're gonna reduce your costs, how you're gonna reduce your footprint, reduce your rejects, reduce your waste. Be a greener company on this way, making the good things on the first time. That's no doubt.
Right. Yeah, that's definitely the truth. So let's talk about cleaning as it related to heat treating, right? So why is cleaning important in the heat treating process? I'm assuming it's very similar to plating, but explain to us why that is.
Yeah, it's a little bit different. I would say we can cleaning in very different kind of process, but cleaning before heat treat, I would say before and after heat treat, it's very important. Mm-hmm. Team, first of all, I would like to explain what is heat treat for everybody. Heat treat, it's a thermal process that use it on the metallic parts that you by having the heat, you change the microstructure on the parts, mm-hmm. and that will be to impact on the properties on the part. That could be on the steel, it could be on the other metals, could be on the alloys, and that will be for extended the shelf life to be harder or to be more ductile, or it will impact on the metal properties. That's why. So normally when we're talking about heat treat, that's the heat. You go and you having the part, it probably came from a stamp or machinery or bending, or the one step before that parts came dirty. I will make really simple, and then go to the heat. The part will be heated, and then we'll normally sit it on the quench, normally oil based, and on the another process is a tempering, which the part is submitted on the other temperature and hold for one time, and that could be various different process of heat treat. So that's a lot of spots that cleaning is crucial.
Right.
It could be before the heat treat, it could be after quenching, before tempering, it could be only a rust preventative after, depends where the part will ended up. But those processes are very important.
Right. And like you said, it could be cutting fluids, it could be release agents from the stamping, right? It could be a lot of different things, right? And they all have to come off.
Exactly, exactly. We made a study on the market and related cleaning with heat treat. This is how the cleaning is. It was being made. 50% is made on the aqueous cleaner.
Mm.
I think that a quarter, like 25% on the solvents, like open top solvents, because there is also a problem if you mix it up uh, products that's flammable with the heat treat with the furnaces. Yeah. So, but today's changed it a lot.
Right.
So 50% aqueous, 25% about that's solvent open top machine. Yeah. And I would say 15% it's the new model, I would say, on the last maybe 10 years. It's applied on the vacuum cleaning machines.
Mm.
And about 10% don't clean at all. It's just go and drag the.
Well, the heat's good enough. The heat will kill it, right? If they think it's food, right? It's the ham. Well, does the heat will kill it, right? But it doesn't, right?
Yeah, actually, the furnace is a good cleaner, because everything that goes on the, if you don't clean well, it will burn off on the furnace, but it will bring some detriment. You will decrease the shelf life of the furnace, actually, and increase the maintenance. That's one problem. And you're talking about what kind of products that we need to clean, what should be on the parts. So when you talk about heat treat parts that are going to be cleaned, what do you have to think about it? So first, all the cooling fluids, all the petroleum based products, right? It comes with corrosion inhibitors as well, some rust preventatives. It could be, you could remove a metallic layer before heat treat. It could be like a parts that came from phosphate,
Mm.
from drawing, or from like tubing, that you have the phosphate on the deformation. So you need to remove before heat treat. Uh, and also deep drawing compounds, the lubricants, those are mostly those products you need to remove before you start the treatment.
So, but now you mentioned cleaning before and after heat treating, right? So that is a step, and so which one do you recommend, or
No, actually, both of them, they're really important, because if you follow the process, so let's say parts that came from a stamping, or a fastener that being produced with the threads, and then you need to remove the oil before go to the furnace, right?
Mhm.
So you have the first heating on the material, and then you need to remove the oil, and then it goes to the heat treat. You have the temperature elevated, let's say 300-400 degrees, and then it goes for the quenching, and then the temperature goes down, and then most of the time you need to clean this quenching before go to the tempering. Okay, so two different situations. One it's before the heat treat, and another one it's after the quenching. Uh, both of them, they're important. Now depends of the part, because there's different specification from the end users. We can talk of different parts, like for example, if we're talking about parts that being normally, what parts suffering heat treat. So we can talk about axles, bearings, camshaft, casings, clutches, fasteners, coils, gears, all those parts, and could be using in different ending. Could be using on the aerospace, for example, or could be used in automotive. Could be used for automation. So it very depends what the customers specify cleaning.
Right. Let me ask you: those who don't do it right, and say the parts haven't been cleaned right, and then they're heat treated or tempered. What are some of the most common problems that happen? So how can you tell that this hasn't been cleaned properly? What are those? What are the signs?
Let's put it on this way: if you don't clean well, what's gonna happen? First of all, that is the most critical. If you have a heat treat, you change the structure of the material, and you need like uniform structure all over the part. So one challenge is if you left, for example, oil behind, and it goes to the heat treat, and then that spot could be a soft spot. It could be one hardness different than the most of the part, and that can cause fail on the part, for example. That is one very common problem on the heat treat. Another problem is if you don't clean well, it could be static, like the cosmetic. The part doesn't it looks good. It's not like uniform light gray, for example, for steel or stainless steel. You see that the part will be more looks like burning, or when you burn the oil on top of the
Right.
the steel. That this is another problem. Maybe the final customer, they don't want this kind of looking.
Right. Especially like I said, if the oil or the cutting fluids, whatever, were on one particular area of the part, right? I mean, sure, it's going to heat treat differently because there's something there that's reacting with the material.
Especially, let's say, if we're talking about blind holes, that's not easy to clean. Or if you have parts, if you have a big load, the parts will be touching each other. That also could be a problem. So that's why you have to think on the right way how to clean the part, because if you choose the wrong cleaner, it could be a problem.
Well, I was going to say, you mentioned you could deteriorate the furnace quicker, right? If you're introducing these contaminants on the parts, right?
So there are two kind of furnace that we have to think on the market. The atmospheric, which is the most common that we see, so that they have the air, they flame, have all the fire to heat it up, the environment. And there is another kind that is a vacuum furnace. This kind of vacuum furnace works differently. That's, of course, the pricing of the equipment is different, and you need a way more refined cleaning when we're talking about vacuum furnaces. But backing, for example, for the atmospheric, if we drag, let's say that you have your cleaner, they're saturated, they're not doing the job well. In some point, you make up, you use for two months, and you start to not clean well parts, or dragging oil on the blind holes, for example, and you're dragging this oil to the furnace. That's really common, actually. First of all, we'll produce a lot of smoke, which a lot of companies, a lot of big companies will be a safety problem.
Right.
Right? Smoke all over. And the second thing is maybe not on the first year, maybe not on the second year, but as soon as you have accumulated this oil that goes all to the wall, and some in certain point it will be a problem to that you have to stop, change, clean all the wall, and that's downtime. And you see how costly is if you need to stop this kind of
Almost like on a home fireplace where you have like creosote stuff that forms, it's burning out of the wood, right? These contaminants that are in woods and things like that.
all the time bringing wood with oil, and you see all the smoking everywhere, and your fireplace is going to be black and build up everywhere. So in certain time, your neighbor, you knock on the door and say, "What's going on?" Exactly. That's the big problem.
Right, definitely. Let's talk about, I mean, what type of heat treatment requires cleaning? I'm assuming, just as a matter of practice, you should always try to be cleaning parts while you're moving them around. But what type of heat treating does require a really good cleaning?
Okay. When we're talking about heat treat, like I explained in the beginning, if you change the temperature, and basically is the temperature range and the timing that you're gonna hold the temperature to change the structure. What kind of heat treats on the market? The hardening, that which is the most common on the automotive and aerospace. So that requires a good cleaning. If you go for a captive, for example, heat treat, or even a job shop, I would say hardening, brazing, nitrating, and carburizing. Those are the big consumer of heat treat process for cleaning. That's another ones that like a stress relief, more temping, aus tempering, FNC. Those kind of heat treat, they don't require, well, but depends. Always depends what is the customer specification.
Let's talk about equipment. So, what does a customer, what does a operation need to know before they go buy a washing machine for the heat treatment? What do they need to know as far as before they go make that big purchase?
Okay, I would say that's a kind of standard for everybody.
Hmm.
So, but if you're gonna talk with the customer that is, for example, we will start a process. What is the most important? First is what kind of oil we're talking about. Give me SDS. Let's see deeply what we need to remove. If it's only oil or grease or something more deeper, it will be a chlorinated or sulfonated, or it's going to contain something heavier. Uh, so that we'll see exactly what kind of cleaner we're trying to pick. Second is what's the shape of the part? What we're talking about, chips, fasteners, or big parts. That will be in the chamber, that will be in the washer. Because so basically we have to think if the contamination will be polar or non-polar. It means it will be water soluble or will be more for the oil side. So we're talking about, first, what is the contamination? Second, what kind of machine we're talking about. For heat treat, I would say a lot of people use a like spray, aqueous. Most, like I said on the beginning, most of the market will use aqueous cleaner. So a spray belt machine that will, like, small parts will be heated, impinged by the cleaner, and then it goes for the heat treat. That's one kind of product. Another one, if you need a better cleaning and go to the aqueous side, and it could require ultrasonics.
Oh, okay. Wow.
Yeah, that's another tool that can be used, especially when you have a blind holes or areas that is very difficult to heat with even using a surfactant, good surfactant. So if you go more for the part of this market, also use solvents,
Mm.
and so more like old hydrocarbon solvents like isoparaffinic solvents, or more halogenated like TCE, trichloroethylene, perchloroethylene, and propylbromide. They use not that much methylene chloride, but also fluorocarbons. And I would say nowadays that is something that is trending. We're talking about modified alcohols, but even on the cleaner. So I spoke about some aqueous. When we go to the solvent, that's mainly two different degreasers that can be used to clean parts before a heat treat. So we can talk about a open top machine, which you have your solvent in a something. You have a heating. It will create like a mist, and the part will be on that environment. You have the chillers, the coils on the top, that the temperature will be lower, and then this solvent will condensate back. So you have this open top machines. So you have the pros and cons. This is one type of machine. Another type of machine, it's more updated machine, is more modern. We're talking about a vacuum sealed machine that you can use certain solvents, mainly, I would say, modified alcohol and isoparaffinic solvents. Those will bring more, I would say, more refined cleaning.
I'm fine with that. Yeah, like there's a lot of options.
Exactly. That's why. Very depends what we're talking about. It's a lot of option. Actually, the best thing to do is stop, see, analyze exactly what is the contaminant, what is the part, what kind of equipment needed, what is the final result that you're expecting. And all when you're talking about the cleaner, so we need to see timing and what's the amount of parts that you need to be cleaned in certain amount of time. And that's very important though.
Right. Wow. Lot to learn. Like I said, I just thought you just put those in there and you heated them up. I'm telling you, you're making it sound like it's difficult. And I'm sure it is, but like you said, if you don't know it, you should find someone like you that can probably come and help you out. And
Yeah, but I would say it's difficult, but not that difficult. I would say years ago, 25, 30 years ago, that's the difference now to the market. I think that all the markets, they're doing like, when you talk about surface finishing or the quality at all, it's different than 50 years ago. Now we don't accept any longer parts, bad parts.
right.
I would say 20 years ago, parts that was treated before, parts that like the oils used, today they're more environmental friendly. All the additives, so it's more difficult to clean, I would say. And so the lubricants that is using on the past, they're more simple. And so on the past also you can clean openly. It was largely used on the market like trichloroethylene and perchloroethylene. So those products, they have they have a limit. They really close to be all the limits, all the exposure limits. They're ever all the time it's getting tighter and tighter and tighter, because also, especially on this kind of open top machines, you see a lot of the vapor that will escape from the machine. So it was really good to clean,
Right.
really easy to clean in the past, but nowadays you cannot use. But on the other hand, you have more technology on the furnaces. You have more technology on the machines. You have more technology even on the chemicals, because today you see a lot of for example, job shops that they receive parts that they have contamination, polar contamination and non-polar contamination, and they need a chemical that will take over all kind of impurities, even metallic layers, for example. And then today I would say machine and chemicals, they're more efficient.
Right. Oh yeah, definitely. And like you said, it sounds like it's like you said, especially with having a professional like you that can really wade through they don't sit there and do all the research, and really, like you said, looking at the part, looking at what the specs are, all those things, and you can pretty much set them up in a very efficient system that they would get them through to making their own customers happy.
Sure. Because even though cost is another problem nowadays, cost is it's something that captive shops and job shops always looking for. If you're talking about the chemicals, so everybody need to or looking to extend the life as soon as they can.
Mm-hmm.
So there was ways to extend life even on the aqueous or on the solvent side.
Well, and like I said, everything you've said makes sure that kind of what our title of our program also just how cleaning is important to heat treat. So, well, listen, Fernando, I want to thank you for that. People can, if they don't see it at trade shows soon or coming up, they can go to your website Hubbard-Hall.com, because you all have lots of information on there, and they should definitely reach out to you and have a discussion about that. I know you definitely will be able to help them.
Yeah, we're here. We're here, team. Everybody know how to reach Hubbard-Hall. Any other technical people from Hubbard-Hall, we're open to discuss all those challenges. And if I make a comment, if you want to do something, do on the first time, on the right time. I'd say does not cut the edges, and try to do as cheaper as you can in the beginning, and then try to scale up and getting better to the years or to the production. It's way better. You do the best thing. You choose the best chemical, the best equipment, and the best process on the first time. It will pay off.
Right. Yeah, definitely. It's good advice. And again, Fernando, I very much appreciate you joining us today and talking about that. Thank you very much.
Thank you so much, team. Have a good one.
Seen Solved is brought to you by Hubbard-Hall. Better results, less chemistry. For more podcasts, go to hubbardhall.com or wherever you get your podcasts.